So I figured I would do just a quick, simple example. You can tell by the title, simple example. Just to really kind of get the point across before you tackle number 5 on your own. Right, so just a simple linear function in 2 dimensions, 2t comma 3. Nothing too fancy. All right, so we're going to let t be equal to some function u that is in terms of t. All right, so we're going to make that substitution. All right, so we're going to make it r of u, allowing for t to vary, right, as a function rather than just as a numerical variation. All right, so 2u3 r prime of u would just be equal to 2 comma 0. All right, if I want the magnitude, that's pretty nice, because that's right along the x-axis. So that's just going to be a 2. All right. So if I'm looking for an arc length parameterization, then what I would want to do is I would want to integrate. So s would be equal to the antiderivative over the interval. Now it's t sub o to t, but we like 0. So we'll say 0 to t of whatever this is, du. All right, so when we anti-differentiate, we get a result of 2u over the interval of 0 to t, which, by the fundamental theorem, tells us that we should end up with a 2t as a result. All right, so then now what we have is a relation telling us that s of t is the same as 2t. All right. If you want to simplify that, you could really just say, or s is equal to 2t, in which case I'd say t is equal to 1/2 of s, or I can rewrite that as t of s is equal to 1/2 of s, because t is a function of s now rather than s being a function of t. All right, but it's really this expression that I'm after, or this equation. Oh, lovely, I highlighted the wrong thing. It's really this equation that I'm after. T is equal to 1/2 of s. So if I want to, and I do, what I can find is r, instead of r of t, I could find r of t of s. All right, which is really, by extension, and after all the substitutions, going to give us r as a function of s. All right, so when I make that substitution, r of s is going to be equal to, if I swap out the t's for 1/2 s's, 2 times 1/2 s. I have nothing to swap out when it comes to the constant component, so comma 3. So I'd be looking at s comma 3, and now I have what's known as the arc length parameterization, because instead of being dependent on t as in perhaps time, change in time, it's represented by the change in arc length.